This is how to finish up your refraction lab and to write your conclusions the correct way. First things first here, make sure you completed page 1. As I have shown here, you need to watch the 2 videos that I linked for you with the teacher demo and also with the pre-lab. If you haven't watched those videos, you're going to have a very hard time finishing this lab. So make sure you do that first and then come on back and do page 1 before you do anything else. And the question you need to ask yourself is as light moves from a less dense to a more dense material, so for example like from air into water or air into glass like we did with this lab, what happens to the angle? Does it get bigger or smaller? And that will help you to complete the drawings here on this page. So make sure you have page 1 completed. Then what you need to do is there are 2 different conclusions. The first conclusion can be found on this page right here, and that conclusion is asking you to take a look at what happens to the angles of light as it moves from air into the glass block and then from the glass block back out into air. And so what I want you to do is to make a quick data table, and you can fit that right in this section here. So you can put your data table sort of to the left over here underneath this paragraph, and then you can put your conclusion to the right in that same spot. And you are looking at all of these angles here. The angle as it comes into the block, and then the angle as it goes out on the top, and then on the other side. The angle that it is in the glass and the angle that it is in the air on the bottom. So we've got all the stuff happening on the top of the block and then all the stuff happening on the bottom of the block, and we want to compare those. So your table should look like this, something like this. You want to take a look at what's happening at the top and what's happening at the bottom for both air and glass. So again, you'll just have your data here, and you're going to take a look, let's just say for ray 2. You can see right here I've got my information for ray 2, and I would fill in on the top what's happening in the air and what's happening in the glass. You want to make sure you're always measuring from the normal line, the dashed line that you put in, not from the edge of the block. So measure from the normal line. And then the next thing you're going to do is you're going to look at what happens for that same ray of light down at the bottom and put in the angle in air and the angle in glass, again, from the normal line. Now, ray 1, of course, this is straight lines, so these are all 0 degrees because it's a straight line. So you can put that in. But what you're going to be looking at is the pattern that you find for ray 2, ray 3, and then also the triangle on the other side. And for the triangle, you'll just pick one side, we'll call that the top, and the other side, we'll call that the bottom. So side 1 and side 2. What's happening in the air and what's happening in the glass as far as angle, measured from the normal line. Then for the last part of the lab, you'll be using your drawing that you made with the laser. And for this one, we only need to look at the information that's happening on the top. And for that, I want to know the incident rays. So I is for incident, the incoming rays. And that's what's happening in the air. And then the refracted rays. And the refracted ray is what is happening in the glass. And you're going to compare those 2 things. And the way you're going to compare it is you're going to go ahead and subtract those 2 numbers, and you should see some sort of a pattern here when you subtract those numbers, and that's what I want you to write your conclusion about, is the information that you see in this data table.